have you ever gone to a restaurant and seen like they have supposed to only face the people that work there, but sometimes they put it on the side. The restaurant says, "Greet the customer, smile." Yeah. So we have something similar for faculty that don't know. Show your students that you care. I can't believe that's here.
Really?
Yes.
This is college.
Identify and offer additional support. I never thought about it.
Just a reminder, Jeff.
Wow. Yeah. All right, guys. So that first one we did. And again, it's all about translating this from math to English. Right? And, yeah, you can almost see it. That's why I like this one. It's a little bit brighter. So I know that symbol log base 3. See that 3 is a little bit down. So that means, guys, that means 3 is the base. The answer is going to be the power that needs. That's why I can think of it in two different ways. How many 3's multiplied by 81, or what power does 3 need to become 81? Either way I look at it, of course, it's 4. Because 3 to the 4th power is 81. That's all logarithms mean. So they're very similar to roots, but roots tell you the power and they're looking for the base. Logs tell you the base and they're looking for the power. What power does it need? So what about part B? It takes 2, babe. Yeah, 4 times 4 is 16. So the question is, how many 4's will it take to multiply to be 16? So the answer is 2. The answer is not 4 squared. That's kind of like the work you would do. The answer is 2 because 4 squared is 16. So that's the answer, 2.
You just write it as 4 squared equals 16.
It's just like
Exactly.
But that doesn't tell me what the answer is. So if I ask you what's the square root of 49 and you write 7 squared is 49, have you told me the answer? No. What's the answer? 7. Right? So if I say what's log base 7 of 49, and again you write 7 squared is 49, you haven't told me the answer. The answer is 2. The power that it takes. Do you guys get that? So be careful. You've got to tell me the answer to a log is the power that it would take. So anything else you write, if you just write 4 squared is 16, I'm going to have to take points off. You haven't told me what the answer is. Now if you circle the 2, then I probably would leave it alone. That's fine. You're pointing out that that's the number. That's the answer. I like it. What about part C then? What power does anything take to become 1? Well, first power, log 7 to the first power would be 7. With 7 to the 0 power is 1. I like it. So notice I can always kind of do this. 4 squared is 16. You can kind of check by looking at it like that. 4 to the second power is 16. 7 to the 0 power is 1. Part D we already did.
So 0 to the whatever power is 1?
7,
What?
anything to the 0 power is 1. This is a property we talked about before.
Okay.
I like it. I like it. And so what's log base 2 of 16? We did that one already. 4. Why? Because 2 to the 4th equals 16. So they are similar to roots, but they're actually, in a way, they're actually easier than roots. This one gives people a lot of trouble, and certainly did today. But the reason it gives people trouble is because it's almost too easy. It's actually just showing you the answer. Because the question it's asking is, how many b's does it take to multiply to become b to the 8th? Well, how many b's do you multiply to get b to the 8th? Freaking 8. Right? And check it. B to the 8th is b to the 8th. Check. So another way to look at this, and I said this on that paper that I asked you to read, logarithms and exponentials are opposites of each other. So another way to look at this problem is log base b and b to a power cancels. So the answer is 8. It's sort of like taking a cube root and then cubing it. They would cancel each other. So in the same way that a cube root is the opposite function of a cube, a logarithm is the opposite function of an exponential. So I can just kill those. Do I have to look at it this way? No. It will help in a later problem. What about part F? Yeah, what power do I raise 5 to make it become 1/5? Well, the only power that turns things over is the negative power. 5 to the first is 5, so 5 to the negative 1 is 1/5. So that should make the next one easier, hopefully. 3 to the what power is 9, just 9. 3 to the second power is 9, and then how do I flip it? I make it become negative. I like it. So it's got to be 2 to make it become 9, but it's got to be negative to make it flip. So how do you check that? 3 to the negative 2 equals 1/9. Check. So again, just to really hammer this home, what question is this asking you? It's asking you 3 to the what equals 1/9. That's the question that it's asking you. So how do I make it become 9? I raise it to the second power. And how do I make it become 1/9? It's got to be the negative second power, because the negative power would make it flip. So real quick, what's log base 6 of 36? 2, because 6 squared is 36. So what's log base 6 of 1/36? Negative 2. Because you got to square it to make it 36, and then you got to make it negative to make it flip. So any fraction stuff here, you just sort of do this first, and then you make the answer negative. Do you guys? Because you're making it become 36, and you're making sure that it flips it. So you're going to make it negative. 2 makes it 36, negative makes it flip. Let's see, what about now? I had to include one on there that was like this dude. What do you raise 7 to make it become 0? Nope, 7 to the 0 is 1. 7 to the negative billionth power is 1/7 to the billionth power, which is not 0. In fact, let's go back to this graph that you had to make and point this out. So on this graph you had to make, it's going to help us out with this problem. And when you plug a negative 1 in, what 2 to the negative 1 is? 1/2. 2 to the 0 is 1. 2 to the first power is 2. 2 squared is 4. So we've got to graph this. Negative 1 goes to 1/2. 0 goes to 1. 1 goes to 2. 2 goes to 4. So it looks like this. This is just growing like crazy. In fact, some horror movies, you hear them say the monster's growing exponentially. This is what they mean. It's just doubling and doubling and doubling. Or the virus is spreading exponentially. Where they show, here's today, here's tomorrow, and the next day is the world. Oh, shit. Now, what's it doing back here? Well, what if I put some more negatives? Negative 2 would be 1/2 squared, 1/4. Right? If I put a negative 2 in, 2 to the negative 2 would be 1/2 squared, which is 1/4. So at negative 2, it goes to 1/4. At negative 3, it goes to 1/8. At negative 4, it goes to 1/16. At negative a billion, it goes to 1/2 to the billionth power, which is still not 0. Does anyone know what I call this? When I get stupid close to something, but I never quite get there. It's called the college experience. No, it's called... I can't relate to it. It's called... Anybody know what this is? It sounds like you're going to call somebody a bad word. An asymptote. Right? So this is asymptotic. One of my favorite words. It means that it's always getting half as far away, half, but it never gets there. So you can never have it equal 0. There's no power that I can raise a number to and make it equal 0. It's impossible. If you don't believe me, try. Try to come up with a number. 7 to the 0 is 1. Right? 7 to the negative 1 is 1/7, and then 1/49, and then 1 over 343, and then 1 over whatever, 1 over whatever. What's the only way a fraction can equal 0 is if the top is 0. Aren't all the tops back here going to be 1 over something? Never can be 0. Never. It can get arbitrarily close to it, but it can't be 0. I like it. So coming back to this question then, there is no power that I can raise 7 to make it become 0, so this is undefined.
That's why I didn't do
I don't blame you. That was one of the freakier ones on there, so if you skipped it or if you gave me an answer that wasn't really right, I understand. But now, do you guys understand? You can't get to 0. You can't raise something to a power and make it become 0. It's impossible. So what about this one? This one's just written in a poor way. What is 0.1? 1/10. So what do I do to 10 to make it become 1/10? Raise it to the negative 1 power. I like it. And what about this one, part F? What do I do to a to make it become 1 over a squared? Yeah, I got a negative to make it flip, and then 2 to make it squared. And then finally, my favorite one. Let me explain this to you in a way that I always hope makes sense to somebody. And you're all like, that sounds like your whole freaking career, Jeff. But, watch this. What does this symbol represent? This symbol, the answer to this symbol, the answer to this would be the power that 7 needs on it to become 12. Now let's say that again. Let's see if you really hear what I'm saying. This symbol represents the power that 7 needs put on it to become 12. So what do I get when I put this on 7? I get frickin' 12. That's what it means. What's another way to look at it? I like the look on, I think I just blew some of Ronald's synapses. Another way to look at this is these are inverses. These are opposite functions. They cancel. That's the way that people like to look at it. Bam! So the answer is 12. It's just like taking the cube root of a cubed thing. They will cancel. But me being the weird math guy in the room, I like the other way. That is the power that 7 needs to become 12. So when I put it on 7, of course it becomes 12. That's what this thing is for. What's log base 2 of 8? That's the one that was on the worksheet. It's log base 2 of 8. So this can't mean division because we already have a symbol for division. So it's not just 8 divided by 2. It's how many 2's does it take to make 8 when you multiply them? 3 of them. I like it. So what do I get when I raise 2 to this power? I get 8, of course, because that power is 3. 2 cubed is 8. Maybe not. So the shortcut would be if I said what's log base 11 of 11 to the m. That cancels out, right? But if I said something like a to the log base a of 2, these cancel out. They always just cancel each other because they're opposite functions.
I don't understand how it works, but I understand that.
So, like here, what's the cube root of x cubed? Yeah, these cancel, don't they? Right? Because they're opposite functions.
I never heard of that.
Uh-oh.
I forgot.
All right. So what's log base 3 of 3 to the x? Well, these cancel because they're opposite functions. And I'm just left with x. Bless you.
Thank you.
Okay, maybe.
So for G, everything goes first. Take out the 7.
You don't take anything out. What cancels?
Cancel the 7.
This cancels with this. So you're left with 12. Yes?
What if it was like not 7 in the front?
Oh, then you couldn't do it. So if I had like 4 to the log base 3 of doesn't matter, 11. I can't do anything with that, really.
That's undefined too.
It's not undefined. This is a number. It's sort of like Tell me now, what's the square root of 11? Tell me. Oh, shit. Right?
I don't know.
All right, beautiful. But it is a number, isn't it? It's like 3 point something, because square root of 9 is 3. Square root of 11's got to be a little more than 3, but that's not the exact answer, is it? So this is not something I can do by hand, but there is an answer to this, right? This is the number that if I put it on 3, it would become 11. Well, I put it on 4, so the answer is going to be more than 11. Does that make sense? 3 to this power would be 11. So 4 to this power is going to be a little more than 11. How much more? I don't know. But it's exactly the same as square root of 11. It's not that it's undefined or something. It's just I can't do it by hand. So be really careful. We're investigating what log means. And we do that by making problems that work well by hand so that we can see what it means. But all I got to do is do log base 2 of 17 instead of 16, and then we're screwed. We can't do that. I know it's going to be a little bit more than... If it was log base 2 of 16, what would the answer be? 4. So I know that this answer is going to be a little bit more than 4, but I don't know exactly how much more than 4 it's going to be. Do you guys see what I'm saying? When you first learn square roots, did they throw square root of 11 at you right away? Of course not. They start with square root of 81, square root of 25, just to see what square roots mean. And then they eventually bring in, well, square root of 26 would be a little bit more than 5. That's all we can do by hand. I like it. Just because we can't, I love you guys though. I want you to realize you're saying, if I can't do it by hand, I don't like it, which is hilarious because students always want calculators to do everything for them, right? So there are some that we can do by hand, but it doesn't take much to make a problem that you can't do by hand. You just estimate this. So here, what do you think the most commonly used base is, considering what our number system is based on? 10. So log base 10 of something. We normally don't even write the 10. It's sort of like, what symbol have we seen that for already, that logarithms are related to? What's the most common root? Square root. Do we even write the 2? No, this means square root, right? Square root of x. We don't write the 2 there because it's the most common one. And again, math people, we are always trying to consolidate or not have to write as much. Right, so we're like, that's going to be used the most. Let's not even write the 2. That's going to be used the most. Let's not even write the 10. So this is what's called the common log. So like log base 7 would be an uncommon log. And yes, there are stupid ass jokes about Abraham Lincoln living in a log cabin and crap. You can look that one up if you want to. Math jokes are some of the worst things. Okay. Now the unfortunate thing for us, and I'm just going to show you this just because I'm trying to remember now if I do this or not. The square root of something, I can actually represent that with the power. So like 9 itself is 3 squared. What does the square root do to something? Cuts it in half. So I could rewrite this as 9 to the 1/2 power. They mean the same thing. And actually, to be honest, this makes more sense. Think about it. So I want to cut it in half, not to where it's 4.5, right? You see what I'm saying? That would be cutting it in half additively. Does that make sense what I just said?
Yeah. I
mean cut it in half multiplicatively. And what's controlled by multiplication? Exponents. So 1/2 in the exponent means cut this sucker in half multiplicatively. So if I said 27 to the 1/3, so the answer would be 3. And to be honest, so to be especially honest, we didn't even need the freaking root symbol at all. We could have just taught pure exponents. That would have actually ended up making a lot more sense. But since these suckers are everywhere, we have to teach that. So what my point is, if I had log base 2 of the square root of 2, So you guys can piece together what I just said. So what power is actually on the 2 for it to be a square root of 2? You can do it. No. What did we just say? Yeah, say it louder. Half. Yeah, so this is 1/2. 2 to the 1/2 is the square root of 2 by definition. I know I just maybe blew some of you away, but hopefully that makes sense. That idea of a square root cutting things in half, it would have been so much nicer if we would have just been up front from the beginning. Just said that that's square root of 4 is 4 to the 1/2. Cube root of something is something to the 1/3. It makes more sense. But that makes it, I just had to tell you that. And it's not going to show up on a test, I don't think, because we don't do fractional exponents here. But just to complete the picture, I mean, somebody hopefully would say, well, I know what negative powers mean. I know what freaking positive powers mean. I know what a zero power means. What the shit does a fractional power mean? Well, now you know. It means roots. A fractional power would mean roots. Okay. It's pretty early, but I don't mind. What are you going to do?
Thanks.
So what's going to happen tomorrow, just to let you know, we're going to get into properties of logarithms. And then I'm going to have a sheet that's going to represent the homework for exponents and logarithms. So that's going to be tomorrow.
So, you have a homework work tomorrow?
Not yet. I'll give that to you tomorrow. Yeah, today you can focus on test corrections and catching up on homework.
Well, you're going back and correcting all your wrong stuff.
And homework, that's the last one.
Yeah, you can do it like this. You can always rewrite a law. That's the base. And I don't know what power it takes to become this. So what do I raise 5 to make it become 1? That'd be negative 1 because negative 1 power means so this would be like this would be 3 to the what is 81.
Right.
Yes, always.
And so that's why they use it. Negative, let me see.
Flip. So if I have a fraction inside, I know the answer is going to have something negative. And then I can just do this. What makes it 9? 2. So I know the answer is going to be negative. So I got that taken care of. And then what makes it 9? 2. Second power, yeah.